The question we are solving now belongs to test series 5. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. As per the question, there is a AC circuit as shown in the figure. It contains a source of Vi is equal to Vm sin omega t, which is connected in series with a resistor of resistance R1. This combination is connected in series with a parallel combination of inductor, capacitor and resistor as shown. So the inductor has a value of L, the capacitor has a value of C, and the resistor has a value of R2. Please note that this is a common data question. As a part of the as a solution to the first part of the common data question, we have found that as seen from the source, the impedance is minimum at omega naught equal to 1 by root LC. That is, if the circuit is operating at a frequency of omega naught equal to 1 by root LC. Now, as a second part of this question, we need to find the current delivered by the source at this frequency. So, upon redrawing the equivalent circuit, we see that the equivalent circuit Vi, so the equivalent circuit in phasor form can be written as Vi is equal to Vm at a phase of 0, and it is supplying power to a impedance Zs. Please note that this impedance Zs needs to be evaluated at omega naught equal to 1 by root LC. This is because of the reason that, as per the question, the circuit is operating at a frequency of omega naught equal to 1 by root LC. So if we see the impedance as seen from the source, it can be written as R1 plus R2 into L by C divided by L by C plus JR2 multiplied by omega L minus omega 1 by omega C, and this is equal to R2 R1 plus R2 at omega naught equal to 1 by root LC. That is, if you substitute for the angular frequency as 1 by root LC. So from this we see that the current delivered by the source in phasor form can be written as Vi divided by Zs. That is, Vm at a phase of 0 divided by R1 plus R2. So this can be rewritten as Is of t is equal to Vm by R1 plus R2 multiplied by sine omega naught t. So we have converted into from phasor form to the time domain representation. Here please note that the current that is flowing has an angular frequency of omega naught equal to 1 by root LC. This is due to the reason that we have analyzed the circuit as a part of this question at an angular frequency of omega naught equal to 1 by root LC. So from this we see that the current delivered by the source can be obtained as shown. Hence the correct option representing the current delivered by the source is C.